I forgot to do one thing.
Oh yeah, yep, I can hear now. Yeah, I can hear.
Test. Seems I can't hear over on YouTube. Testing.
Can still hear you.
Test. Is it just me or my voice is not on YouTube? No, it's just very soft. It's just very soft. I think your
You still
voice
hear
is
me
louder
now?
than mine.
Yeah.
Okay, cool. How come? Maybe I can do something. Is it this one? Okay, maybe I need to speak louder. Ah, okay. Time to go back to some music. Still 1 minute to go. Hello, good evening, everyone. I hope my voice is loud enough to so that you can hear me clearly. Steven, please let me know on WhatsApp if the YouTube and things like that too soft. Hello, everyone on YouTube. Thanks for tuning. Please let me know on the chat if my voice is too soft because now it's uh, like working from home, so I can't speak too loud. Otherwise, my neighbors will start to make a police call or something. Okay, okay. So let's begin. Thanks, Steven. Okay, so I'm Chun Lin, as usual, your community lead of ACS Azure Community Singapore. Okay, thanks for joining us tonight. And here's my Twitter together with my blog. So I'll always tweet about like Microsoft Azure stuff or some cloud computing and .NET. But recently I'm mostly focusing on Azure storage as well as Azure API for Fire, which is I just started recently. So if for those who are interested, can subscribe to my Twitter and listen to my reading my blog post. Thank you. So welcome once again. Welcome to our meetup. If you would like to share and join our meetup, you can always feel free to join. And this is our link, meetup.com/AzureSG, and contact us here. Riza is our main guy here, and we have 3 others co-organizer, which is me, Marvin, and Priyanka. So if you would like to join us to be a speaker, just drop us a message over the meetup. And we conduct a lot of meetups in different forms. For example, now is YouTube, and before COVID-19 hit us badly, we have a talk and discussion which is in person and workshop, but we can't do that now. Hopefully soon we are able to meet again in Microsoft Singapore building. Okay, so for those who are interested, like to share your personal open source projects, we have some samples available on our GitHub repository already, which is github.com/sg.net, as you can see over here. So if you have some that you would like to share and onto your resume, then you can always feel free to upload. It's an open community. And finally, thanks for those who always drop by our YouTube channel. Thank you very much, and please subscribe to our channel if you haven't done so. Currently it's 186. We need more because according to YouTube, without hitting 1000 I can't do like sharing as a community on our YouTube. There's this bar, so I need your help. This 5.4k is a screenshot from somewhere else. It's not our channel, but I hope we can reach here somewhere soon. So since this online sharing, please remember to guard your privacy. So if someone asks you for a credit card, don't share it online. Feel free to ask your question in the chat at the site or on mobile, which is at the bottom of the video. And speaker tonight, Steven, will reply your questions and go through them one by one later after he's sharing in his Q&A session. Yeah, so today we will have a speaker from Microsoft Singapore, Steven Lin, who is a premier field engineer. So today he will go through with us 2 topics on Azure IaaS. So for those who are very familiar with, who heard about virtual machine and would like to know more, so this is the topic for you. And we have 4 sessions in total. So tonight we will cover the first 2, and next week on 7th of July we will cover the remaining 2 at the same timing, 6 p.m. Singapore time. Okay, so without further ado, I will give the chance to Steven. So let me go to the we are using Skype, so let me mute myself, and Steven, you can take over. Thank you.
Sure.
Thank you.
Hi, everybody. Thank you. Thank you, Chun Lin. Hi, everybody. Welcome to our live feed. I have not done this kind of a live stream before, so I'm not too sure what to expect. I think there will be some delays between what you're seeing on my screen and what I'm actually talking about. So, okay. Yeah, okay. So I will look through all of the questions that you have as I go through the content this evening, and I will answer them perhaps at periodic breaks. So I won't be actively monitoring the chat, because otherwise it would be quite distracting looking at like a 10 seconds in the past version of my presentation. That's it. Don't feel free to ask your questions. I will answer if I can. A bit on the mode of presentation this evening is not going to be, there won't be any slides. It will be primarily focused on either whiteboarding or through demos. So just to set some expectations, there will be some wait time as I do intend to create resources on the fly as I show you how to do things rather than just the theory. I think 2 months ago, you attended, or some of you who are on the stream right now may have attended some of the Azure IaaS theory. I think that was presented by one of our partners. And then I think he did a good job of summarizing what Azure as a platform can do. And what you see on the screen right now, right, is kind of like a representation of some very common terms: infrastructure as a service, platform as a service, software as a service. And towards the extreme left, you have on-premises. And I think I will spend a bit of time here going through this theory again, no more than 10 minutes, I hope. And then we'll go right into the topics of not just how do you create a VM, like that is probably one of the more trivial things that we'll talk about tonight, but all the things before that and after that. So we'll be exploring topics like, how do you do governance as if you are an enterprise, a medium-sized or a large-sized enterprise trying to adopt Azure? How do you have a set of policies that you can apply at either subscription level or beyond that, so that things can be automated as much as possible and people are, have to follow the company policies by design? We'll also talk about things like, how do you make sure that your virtual machines are highly available? For example, if you have just one single virtual machine hosting a single workload, could be a website, could be an app server. And if that VM goes down, either due to one of our maintenance operations, or if someone shuts down that VM or that VM crashes for some reason, how do you maintain the availability of your workloads and applications? So those are the topics that we'll be more focusing on. The expectation that I have of the audience is you should have a baseline understanding of infrastructure services. And so just riding on that 1 hour, 1.5 hour sharing of, by our partner 2 months ago on the fundamentals of Azure infrastructure as a service, I will be going through, I won't be explaining the very basics, but I will be going through demos, and I'll be assuming some level of understanding of infrastructure as a service, but you don't have to know very deep, right? Or if you know very deep, you can, present a topic on your own, and I think that would be very welcome by the community. Okay, so logistics aside, we can begin. So if you look at what I'm showing you here on my whiteboard, right, essentially we have the different cloud models. A lot of our customers, so a bit about myself, sorry, I forgot about that. I'm from Premier Support within Microsoft. So you can think of me like some kind of a support engineer, except that I don't support consumer products. I don't do PC repair. I do mostly Hyper-V, failover cluster, Azure AD, and also Azure infrastructure as a service. So more of the enterprise stuff rather than the consumer stuff. And where I'm engaged with my customers, we do not just reactive work, which means reactive being will be involved in troubleshooting issues that our customers face of our products. We also do proactive work like assessments. We also do things like architecture services. We do things like remediation of known issues. So depending on what the customer needs, we might have tailored services for them. So we are not a department that tries to sell products. We are not a department that markets our existing products. We are here to support our customers on either adoption or operations or optimization or maintenance. We also do a fair amount of workshops. But I won't be using any of those content because those are copyrighted by the company. But I will be using a lot of demos, so I don't think you will be worse off. Okay, so let's begin. So a lot of our customers in Singapore are really on the left side of the scale. They have a lot of on-premises workloads. A lot of them have up to like 80% of things still running here, and maybe 20% here, or maybe 19% here and 1% here. So in other markets like Australia and New Zealand, they are more mature. We do have something like 20 to 30% already on the platform services side. And I think in 5 to 10 years' time, I think 2 to 5 years' time, actually, Singapore would move towards that direction. Okay, so numbers aside, let's go into what these things are about. So on the left, you have pure on-premises infrastructure, which means that you are responsible for everything in the stack. You would be responsible for laying the network cables, signing up for telco contracts. So you'll also be responsible for buying the servers, picking which SAN storage to buy and what kind of hard disks. Are you still getting SAS hard disks, or are you getting SSDs today? How is your storage replication strategy like? So you have to choose between all these things. You then have to choose what kind of servers you want to buy. Would that be Dell, HP, or build your own using Supermicro boards and so on. You'll then choose a virtualization agent, whether that is Hyper-V, VMware, Proxmox, VirtualBox, or more. So, I mean, compute power these days on one single PC is typically very ubiquitous, right? Like, for example, if you take a look at my desktop here, I have 64 gigs of RAM and 12 threads on this machine. So it would be a waste to just run one single environment. So then it makes sense to run virtualization, which means many more servers and computers can then run in the same environment. So if you're on premises today, you have to think about those hardware components. What is the technology for virtualization that you choose? What are the host operating systems and guest operating systems that you choose that runs on top of virtualization? What are the middleware and runtime? So for example, the drivers that you install on the machine, as well as are you going to install Java or .NET or Ruby on Rails or one of the other good frameworks that you have to run your applications. And above that, you then have to decide how to populate your data, be that as a file server, as an SMB file share, or as database servers like transactional databases like MySQL and SQL Server, or not only SQL instances such as DocumentDB or MongoDB. And then on top, and if that top layer is not meant to serve data, then that top layer is meant to serve applications, be that a Java applet or a web page running off either IaaS or Apache. So those are all the options that you have to choose, and those are things that fundamentally that you have to make those decisions and you have to own end to end. So that is the on-premises world. Right? When you move into the cloud or commercial cloud, that could be AWS, that could be Azure, that could be Google Cloud Platform. No matter the cloud platform that you choose, right? These terms will remain constants. And let's take a look at the differences. For infrastructure as a service, a lot of the underlying layers are taken care of for you. So if you use Azure, for example, we would be in charge of pulling the network cables. We'll be in charge of the underlying storage. Are we using HDDs or SSDs or the kind of storage controllers that we are using, the kind of server boards we're using on our servers? Are we using Supermicro or are we using some other brand, or do we build in-house? So this is a bit of an insider fun fact. We do have collaborations with Intel, and Intel builds very custom, or not very, but slightly custom processors for us to run in our servers. So those are slightly tweaked versions of Xeon processors, so Xeon chips. You can't buy those from Intel because those are exclusively for Microsoft, but we do have a hardware division where we collaborate closely with our hardware partners to come up with enterprise chips customized for our use case. And then we do run virtualization in the sense that almost all of our cloud is powered by Windows Server, and it's the core edition, so it doesn't come with the GUI. There are a lot of things that are stripped away from the virtualization layer, so you don't have things like print spoolers and unnecessary drivers or services that are running that don't directly contribute to their meaningful lifecycle as Hyper-V virtualization machines to host the servers that we have within Azure. So in infrastructure as a service, all of these are taken care of by Microsoft. So you don't get to, for example, touch a router, or you don't get to touch the server, you don't get to open a server tray, swap up some RAM, and swap out the hard disk. You don't get to do any of that. The point that you have control is at the operating system layer, as you can RDP or SSH into a guest operating system that runs on top of our platform, and you can do everything. You are in control of everything from here up. So you can choose to install Linux or Windows. And then on top of that, you can choose to run .NET Core or Java or one of the other platform stacks. And on top of that, you then can choose to run different database softwares, or you can choose to host your applications. So that's infrastructure as a service. And this is what Chun Lin meant when he said to create a VM. When you create a VM, by definition, you are using infrastructure as a service. Okay, so you do have to think about things like patching of the OS. Every month when Microsoft releases an overall Windows update, you are responsible to patch that, which also means that you can choose not to patch that. In exceptional circumstances, we might mandate a patch, and we might give you a time frame to do that. But most of the time, we don't mandate patches. So the time that we mandate patches is typically when so we are a public cloud provider. One of the most fundamental things that we need to make sure is that our platform is secure, right? So the entire secure multi-tenancy model that we adopt, which means that if within a physical host, right, ABC company is running 30 VMs and XYZ company is running 20 VMs. So at no point should the VMs between the two companies be able to interact with each other unless the companies explicitly grant each other the permission to do that, right? So if there exists an exploit, such as Intel X-Factor or Heartbleed in the past, and if that allows other VMs in the same physical host to exploit the processor instructions or RAM information belonging to other customers within the same physical host or even within the same rack or data center, then we will mandate the necessary security patches so that we don't put the rest of our customers at risk. But otherwise, you are responsible for patching the operating system. Likewise, for runtime and middleware, as well as your own applications. But by the time it hits the application and data layers, typically there isn't so much risk to other customers, because it's very high up the stack. Okay, so that's infrastructure as a service in summary. Now let's move on to platform as a service. So I know a lot of the people in this meetup are actually developers. You come from .NET or other programming backgrounds. So you might be familiar with things like web apps, app services, logic apps, functions. So those things are known as platform as a service. How does that work? So if you take a look at this chart again, the number of stacks that is taken care of by Microsoft has increased. So not only do we care about the networking up until virtualization layers, we also care about the operating system, the middleware, and the runtime. So for example, when you spin up a web app, you can choose to run it as a PHP application, And you can choose the version of PHP that your application will be hosted on, and we'll make sure that entire stack is created for that application, beyond which you are not responsible for patching the runtime, you are not responsible for patching the OS, you are also not responsible for high availability because that is inherently built into the platform service. All you really need to care about is the data that you put in and the application code that you host. So platform services can exist in many different factors, right? One of them, of course, is something that you are most familiar with, web apps. I call them app services. And the other side are data services like SQL as a service, MySQL as a service. We also have Cosmos DB, which is our implementation of not only SQL service on top of Azure. So in all of these services, you won't have an endpoint to RDP, you won't have an endpoint to SSH. In these services, what you really do is you only worry about the application, the data, and you leave the platform provider to worry about everything else down the stack. So that's platform as a service. And for software as a service, these are things that we know of as consumers. So I give you some examples. YouTube is a software as a service. LinkedIn is a software as a service. Gmail, OneDrive, Teams, Netflix. All of these are examples of software as a service. Facebook. So in all of these services, the commonality is you don't have to think about what are the underlying compute mechanisms that are powering the service. So for example, if you post something on Twitter, right? Like you upload an image and you post your text, you won't be worried about what is the number of CPU cores of the VM that is powering my web page view right now, right? It's not something that you care about. Or if you're watching one of your favorite shows on Netflix, you would not be thinking about how much RAM is available on the server that is streaming me all of this good content. That's not for you to worry about, right? So some Microsoft SaaS services that we have as an example for enterprise use are SharePoint Online, I mean, Office 365, Dynamics 365, Power BI, Azure AD, Azure DevOps, and so on. So there is not, it's by no means an exhaustive list, right? So I just wanted to, after showing all of this, I just wanted to tell you that for today's session, we'll be focusing primarily here and just here only on infrastructure as a service. And in our next session, we will be touching on Azure DevOps as a service, but we will not be going deep into managing software as a service as a practice. Okay. So with that, let's begin on the right. I mean, this is really just an introduction. The real technical content starts now. Okay. Right. So let's begin with some fundamentals. We all know of Azure subscription, right? So let's say you have a subscription one, right? Within this Azure subscription, you can have resource groups. So you can have resource group 1, you can have resource group 2, you can have resource group 3. And within a resource group, you can have resources. So that's resource 1, resource 2, and resource 3. Right? So note the relationship between these things. A resource group must belong to one and only one Azure subscription. An individual resource must belong to one and only one resource group. So as an example, resource 1 can be a VM. This VM must be part of a resource group. This VM cannot be simultaneously part of 2 resource groups. This is not possible, or not logically possible in Azure. Okay. Another thing that's not possible in Azure is a resource cannot be directly packed under a subscription. Right? You can't have a resource that is not part of a resource group. This is also not supported. Another thing that many of my customers ask is, well, can I then have a resource group within a resource group? So this is also not allowed. There is no nested resource groups available. everything is flat in hierarchy. Okay. So all of these are very fundamental information, but you have to know this. Because when it comes time to govern your Azure subscriptions, Azure resources, if you don't know this relationship, the governance portion can be a mess. And one thing I need to state beforehand. For those of you who have already adopted Azure, you would know that Azure is not a forgiving environment. If you create any resource, right, you can't rename them. Like if you create a resource group, and then you start to put resources into that resource group, whether you put any resources or not, you can't rename that resource group. And as another example, once a VM joined a virtual network, you can't shift it into another virtual network. You would have to go through the process of replicating the VM, deallocating and deleting the VM, and recreating a new VM in the correct virtual network, as an example. So my point here to not just you, but a lot of my enterprise customers is planning is crucial. It is very important to get the governance piece right before you even implement anything. Because if you do implementation first and you realize that things go wrong afterwards, then the amount of effort and time that you'll spend to remediate the situation would be a lot longer than setting things up from scratch. But of course, by then you would have data, you would have customers. It would be a very painful experience that you don't want to go through. Okay. So everything that I've shown here is within the context of one subscription. Now, what if I bring in another subscription into the picture? So let's say I have a subscription 2. Of course, subscription 2 can have other resource groups. Let's call this RG5. Let's call this RG6. Within resource group 6, there could be another resource like resource 4 and resource 5. Now, question, can resource 3 be part of RG6? Well, the answer is no, simply because, once again, I mentioned that a resource can only be part of one and only one resource group, which also means by implicitly, a resource cannot belong to more than one subscription at the same time. So if resource 3 is a VM, this VM belongs to resource group 3, and resource group 3 is part of subscription 1. This VM will not be part of subscription 2. You can go through the process of moving resources between resource groups and even between subscriptions, but that's, again, not going to be a smooth process, as a lot of our resources have dependencies on each other. And if you move things not at the same time, you might get into a very sticky situation where you get a deadlock situation where moving one, you break the other, and if you move the other, you break the original one. So in those cases, you have to log a support ticket, and our support engineers have to help you via some backend configuration that we have to do for you. Okay. So between subscriptions, so at this layer, this is not the topmost layer, right? Because every Azure subscription is also part of an Azure AD. And I'll show you later on what I mean, but every single Azure subscription is part of one and only one Azure AD tenant. So if you spin up an Azure trial subscription today, you'll realize that your subscription is part of, let's say if you spin up your subscription using, say if I spin up using Stephen Lee at hotmail.com. That's not my email, by the way, so please don't send emails there, as someone else would probably receive it. So I'm just trying to give you an example. If you use this email to sign up for an Azure trial, and these will result in a new Azure subscription created just for you, and you realize that this subscription would belong to an Azure AD tenant, and that Azure AD tenant will be something like Stephen Lee Hotmail on Microsoft.com. Okay, for those of you who are in enterprise, you will have something called an enterprise agreement with us. So that's a contract that you sign with us every financial year, and as part of that contract, you would have pre-purchased Azure credits, and as part of the setup, you would already have a company Azure AD. If your company employs Office 365, then you would already have a functional Azure AD. because Office 365 would only work with Azure AD as a login agent. So for those of you who have existing Azure AD in your companies, then you would have any number of Azure subscriptions that are created under that Azure AD, and I'll explain to you what this purpose is in a minute. So you should not be creating new Azure AD tenants. It's also the reason why you should not be creating random trial subscriptions or pay-as-you-go subscriptions if you're part of a company that subscribes to Azure as part of the enterprise agreement. Okay. Now, why? Why are subscriptions all part of an Azure AD tenant? Okay. The reason is this thing called RBAC. Perhaps I should write it vertically. So R stands for role-based access control. Okay, so what these means is essentially a permissioning mechanism where you would allocate permissions either at a subscription level, a resource group level, resource level, or even a group of subscriptions. So you can technically, let's say you have subscription 1, subscription 2, subscription 3. There exists this thing in Azure called a management group. And it looks something like that. So this management group allows you to group multiple subscriptions together, and you can have a hierarchy, like a layered kind of experience on management groups. So you can have subscription reporting into here and management group reporting into the same thing. So what are management groups used for? So remember, I can say that I said that you can allocate permissions at a subscription level, resource group level, and a resource level. You can also allocate permissions at a management group level. So if, let's say, I allow John to be an owner of this management group, then John, by definition, will also be an owner of subscription 1 and subscription 2. But if I just allocate John as an owner at this level, then subscription 3 is not within the scope of this management group. So that means that John will not be an owner of subscription 3. In fact, John will not even be able to see subscription 3 when he logs into Azure. Okay, but if I allocate Jane to be an owner of this management group, or what we call the root management group, then this management group, so all the subscriptions roll up to this management group. So all the resources or all the subscriptions and management groups underneath this root management group will inherit the permission settings that I have assigned here. So if I assign Jane as an owner at this level, then all 3 subscriptions are within scope, and she will be an owner of all 3 subscriptions. Right. So let me show you what I mean based on all these things. Okay. Here, I have an Azure. So if I first of all, let me just show you the account that I'm logged into. I'm logged into admin@mdyn.org. And if I go into subscriptions, you can see there are 2 subscriptions that I have access to in this tenant. If I just click any one of those subscriptions, and if you look at the directory, can you see what's being shown here in directory? Okay, this directory field shows you exactly what the Azure AD tenant is that this subscription is associated with. Every subscription will have a unique subscription ID and the Azure AD tenant. And each Azure AD tenant will also have a tenant ID, but that is out of scope for today's discussion. Okay. If I go into the other subscription, you can see that this is a different subscription ID, but it's also essentially part of the same directory. Right? So this is what I meant when I said that every single subscription is part of an Azure AD tenant. Now, if I go into resource groups, you can see that there is a list of resource groups, and you can see that there is no stray or child resource that is not part of any resource group. And if I go into a single resource group, you can then see the resources that are part of that resource group. So any one of these resources would belong to this resource group. In this case, this is like, I think it's a game server that I'm hosting. So if I go into this VM, and if I go into this properties field, you can see that under this resource, there is a resource ID, right? Let's take a look at this resource ID. What does it contain? First thing, you have the subscription that this resource belongs to, and then followed by the resource group that this resource belongs to, and the type of service. In this case, is a VM, so it's parked under Microsoft.compute, virtual machines, and this is the name of the VM, right? Can you now see what is the impact if you try to move this resource across to different resource groups or subscriptions? Because the moment that you move this, the resource ID will change. So for example, if I go into this virtual network interface card, which is part of that VM, and if I go again into properties, you can see that there is once again a resource ID. If I try to move this resource ID out, right? I mean, if I try to move this resource out into a different resource group or subscription, then there will be a break because as far as the VM is concerned, it is linked to this virtual network interface card. And when that network interface card disappears, the VM will stop working. Therefore, if you just try to move this virtual network interface card, you're likely going to fail. And so you have to move both together. Otherwise, it won't work. Even if you move both together, there is a chance that the mode of operation is not supported out of the box, and you might have to log a support ticket in order to get those moved per your design or per your change requirement. Okay, so back to my drawing, you can see that we have resources under resource groups and resource groups that are part of a subscription. Now, how does role-based access control work? Right. So I can go into subscriptions and say if I go into any one of these subscriptions, and if I go into access control, role assignments, you can see these are the people who have access into the subscription at various different access levels. So my Microsoft employee account is a shared owner of this subscription, even though this ID belongs out of my Azure AD tenant. But you can see that, for example, this user who is only allocated the permission to read log analytics resources is part of my Azure AD. So for example, if I choose to add a role assignment, and let's say if I added another owner into the subscription, this is pulling up a list of identities that are part of my Azure AD tenant. Okay, this is a demo tenant. It's not my customer, so a lot of them don't even have mailboxes. So they won't be able to receive emails as an example. But let's say if I choose to delegate owner access to William Bell and I press save, then William Bell will have access to this subscription, but not the other one. So as an example, if I could move on to the other subscription and I check again the role assignments, can you see this is a different list? Okay. For users who are given control at a higher level, you will see this thing called inherited. So for example, you can see management group is inherited. Why? Because this is a service account, and this user access administrator is assigned at a management group level, which is one level above the subscription level. So if I delegate access at a management group level, then all the subscriptions within that management group will be in scope of any of the settings that I set. So this is an example of setting access control at a subscription level. Now, if I move, so I've shown you how do you set permissions here, right? Now, if I just moved one level up and I show you the management group level, in my tenant, I just have one management group, and this is the tenant root group. Within this tenant root group, there are only 2 subscriptions. And if I go into the tenant root group details, I can also go into access control, right? And if I go into role assignments, can you see that I have 2 accounts assigned access at a management group level, which means all subscriptions within the management group will inherit the same role-based access control settings in their respective RBAC controls. Okay, now, one thing that I wanted to show you is also within resource groups. Okay, so I shown you that you can delegate access at a subscription level, at a management group level. Now, let me show you how you can delegate access at a resource group and resource level. So here I have a list of resource groups. If I go into this resource group and I go into access control and I go into role assignments, you can see that, okay, so this belongs to Steven's Visual Studio Enterprise subscription. So if I go into Visual Studio Enterprise and go into access control, I'm currently lacking people here. So I'm just going to add someone. So I'm just going to add a reader for Hikari Yagami. And I just save. So when this user signs in, this user will be able to see both subscriptions. She will have read-write access into the other subscription, while she has read access into just this subscription, right? And if I go into resource group and I go into this resource group, now I go into access control and role assignments, can you see that this user has inherited access into this resource group because she has been delegated reader access at a subscription level? Now, if I do, I can also click and add role assignment. Let's say I assign Brendan Fayette as a reader to just this resource group. I can save. And you can see that in a moment, Brendan's name will show up here. See, so Brendan has read access into this resource group. And if I go into a different resource group within the same subscription, and I go into access control, you will be able to see Hikari, who has subscription level access, but you won't be able to see Brendan because he is not allocated access into the resource group. Okay. Right. So when Brendan signs in to Azure, he will be able to see just have an MS resource group, but not anything else. He also won't be able to see the other subscription for which he has entirely no access. This is how role-based access control works within Azure. Okay. I'm just going to read one question that I see here on the YouTube live chat. Alice Chia asked, do you recommend any best practice or convention for resource group naming since we cannot rename it? Yes, as a matter of fact, there are multiple ways to do it, but the only best practice that I have to offer is make sure that you have a standard. And it depends on how big your organization is. So if you are a multinational company, you could first start with the country code, followed by department, followed by application name, followed by the resource, say is a VM, followed by the instance, say VM01. Right. And if you happen to be a company that has multiple different subsidiaries under you, so for example, Microsoft has LinkedIn, has Office, and so on, right? So we can have linked. So first of all, LinkedIn, followed by Singapore, followed by the department marketing, followed by web page or whatever web that we refer to, followed by VM and 01 as an example. Obviously, if you don't have, so if you are a small company that don't have or only have operations within Singapore, you may choose to ignore or omit this country. But just to be very aware, if you expand out overseas, right? Let's say you expand operations into Malaysia or Thailand or Korea in say 5 years down the road, you can't change this. So it's always good to plan in advance. If you have plans to expand overseas or to expand the scope of your business, then the resource group naming should reflect that. There are many different tools that can help you with the identification of different resources, and that is called tagging, which is the next thing that I'll go into. But having a consistent resource group naming convention would help you identify the resources that you have hosted on Azure in a much easier way. Okay. Right. So, okay. So as of this point, as you can see, we haven't even gone into the conversation of networking or storage or virtual machines. We are still at the topic of governance. And in the governance topic, there's still one other major topic that I'd like to go into. But before that, let me just talk a bit about tagging. So you guys used Gmail, right? Like you must have some experience with Gmail. Gmails allow you to apply labels to your email. Each email can have more than one label. And the idea is you don't put emails into folders, but email would be, they can belong to multiple labels, right? Resource tags within Azure are exactly that concept. Like if you go into, so this is my Microsoft employee subscription. If I go into, say, this resource group, say if I go into network backbone, can you see that I have a list of tags here? As a best practice, you should always provide owner, environment, and application. But this is baseline. So what I mean is, so when you create a resource group, what are the things that you will put into the resource group? Most of the time, our practice is not to put all of the resources of the same type into a resource group. That is not how resource groups are meant to work. You are supposed to group resources of a similar life cycle into the resource group. So as an example, if you have a finance application, and as part of supporting that finance application, you have 6 virtual machines, 2 database as a service resources. You might have one virtual network, 6 VMs, so 6 network interface cards, a public IP address, and so on. So all of those would fit into the same resource group, because if you decommission that application, then all those resources will be decommissioned together with that application, right? So when you put all those things, all those different resources into a resource group, what you should do then is to tag that resource group to say who owns the resources within this resource group. What is the environment? Is it production? Is it pre-prod? Is it UAT? Or is that something else? And also, of course, what is the application? So if that is a finance application, then state the name of the finance application. Why? So I've had customers, I think this was an Australian customer. They reached out for help because they have been running Azure for something like 7 years now. And in these 7 years, there has been a lot of people movement. So a lot of their old IT operators have left the company and new IT operators have joined the company. And there have been a few cycles of people movement across 7 years. So the people who are governing the Azure subscriptions today don't have any idea who are the ones who created some resources and what are those resources supporting. So they might have a resource that could be incurring like $1,000 a month. But because they don't know what it supports, they are afraid to delete it. Because if they delete it and it's supporting a critical component of their infrastructure, then there will be critical situations that they will have to deal with, right? And to maintain, or rather to restore services could be a challenging task. But at the same time, if they don't do anything to clean up their resources, they will have to additionally incur $1,000 month on month, which is also not ideal, right? So it's doing the company a favor if you just tag everything that goes into the resource group, and every single resource that goes into the resource group should be given similar tags, if not more. So as an example, if I have a virtual machine, which I don't here, but if I have a virtual machine here, I would also include more tags like what is the size of the virtual machine, and what is the updates lifetime of the virtual machine or update life cycle, right? Why? This is all to facilitate automation. It's also, if you're not at the level of automation, then it facilitates at least a basic level of tracking. So if you have VMs that have different update cycles, you could group them into different resource tags, and you could then apply updates based on the tag value. So tags is just a key value pair, right? It's like a hash map or a hash set. I mean, dictionary if you're a .NET developer, I think. So it's just that as you create a resource, you are allowed to create tags as part of creating that resource. It will also help you in your billing. A lot of our customers are confused what they're built with because the bill only shows a list of resources and how much they're built for each resource. It doesn't show, finance application is costing $800, HR application is costing $200, and customer-facing application is costing $12,000. They don't have that kind of insight. But if you group or if you tag your resource groups and resources, then you can easily filter the subscriptions and the billing by those tags. This is another use of tags. Now, it does get very tedious if you have to input tag value for every single resource that you create. So if I create a VM and I put in tags, and then I create a storage account, I have to put in the tags. And if I create different other resources, and I still have to put in the same tags, because when you create tags in the resource group, right, the resources that you create as in that resource group will not automatically inherit those tags. As a result, you will still have to create the tags manually for all the resources that you put into the same resource group. So we have a feature called Azure Policy that can help you with that. So there is this thing called Azure Policy. And Azure policies are a bit like, for those of you who have run domain controllers and you know of this thing called a group policy object or GPO. And if you group multiple servers into a GPO, you can apply one single set of policies, and those settings will be effected onto all the VMs within the GPO, right? So likewise within Azure, you can apply a set of policies, again, at a subscription level, at a resource group level, or at a resource level, or even at the management group level. So it depends on where you assign the policy, that affects the scope of that policy. There are I can give you some examples of policies that customers often use. One good example of policy is location. So you can have a policy that says any resources that is created out of Southeast Asia, the effect is to deny. So if anyone tries to create a resource group or a virtual network or a VM, say in East Asia or UK South or East US, those creation will all fail because they will fail the policy check. If you apply this policy at a management group level, then all the subscriptions will inherit it. Another very useful policy is to enforce tags. So if you enforce tags must exist on resource group level, and tags from resource groups will inherit or will apply the tags to all the resources, then that would ease the tagging process for all the resources. So let me show you an example of a policy in function. So if I go into subscriptions and I go into internal consumption alpha, I can go into this thing called policies. And if you take a look at policies, so I do have a list of policies. In fact, I have 6 of them. I really do just have 2 different types of policy objects. One is to make sure that when you create a resource group, you must have owner tag, application tag, environment tag. So if anyone tries to create a resource group without these tags, then the resource groups will simply not be created. The other set of policies is all the resources that are part of a resource group will inherit the value of the tag from the resource group. And the tags that they will inherit from are owner, application, and environment. So let me show you a demo right now. So if I try to go ahead and create a resource group, and if I try to create it in this very subscription, let's call it test. Oh, one thing that you can apply by policy is also the naming convention. You can have, I can't remember the term, but you can style a string, right? Using this notation that I forgot. But you can define a pattern. I think regular expression is what I'm looking for. You can define a pattern for the naming convention of resource groups or resources. But just be very careful not to apply the same naming convention to all resources, because some resources have very specific requirements. If you create a storage account as an example, or any other resource that winds up creating a public FQDN, so fully qualified domain name, basically it creates a URL. If you create a storage account, it creates a URL. And as part of that creation, you cannot have uppercase characters, you cannot have dashes, you cannot have spaces. So if you applied a policy that contravenes with the limitation of naming convention for a particular resource, what you wind up doing is you create a scenario where that kind of resource simply cannot be created, and you don't want to be in that position. Okay. So let's say if I start to create a resource group called test, and let's say if I create it in East US, next text. So here, I'm just not going to fill in any text, and I go into review and create, and I just go ahead and create. You will see that this action failed. And if I view the error details, the resource test was disallowed by policy. Okay, what is that policy? If I go into the raw error, which is really a JSON document. Okay, can you see there are like there's basically this error, require tag on a resource, require tag on a resource, require tag on a resource. Okay, and the specific name of that rule is here. So I missed the environment tag, I missed the application tag, I missed the owner tag, right? So if I go back here and I go to previous, I create an owner tag. I create an application tag. I create an environment tag. And now I try to create this. This is successfully created. So can you see how you can, through the use of policies, help you implement governance tools that would make your life as an Azure operator or administrator a lot easier, and to bring alignment from execution into the company's business policies, right? Now, just to test the other policy, if I try to create a new resource, so let's say if I create a virtual network, storage account. I'm just thinking which one is the easiest to be created. So once again, I create test, storage account name. So here you can see if I put in symbols, this will not work. If I put in capital characters, this will not work. If I put in dashes, this will also not work. So it has to be also unique. If I put in this, it will tell me that this is being used. Why? Because this will create this will create FQDN, a URL basically. So let's say Steven demo test. Okay, so it's available. All right. And I just want to check what is the so let me just so this is created within forgot the location that I created in. I think it's US. East US. Okay, so let's create this in East US. Right, so networking, I'm not going to go through this as of now. I'm just going to show you that I'm not going to put in any text, right? And I'm just going to create it. you'll see that the moment that this storage account is created, you will also see that the storage account will inherit the tags from the resource group which it belongs to. Maybe I shouldn't have chosen this resource type. It's going to take some time. I see a comment. There is character and special characters limit on resource type. That is in general true, right? There are some, so for example, on resource group, you can't have space, but you can have uppercase characters, you can have dashes. Your name just cannot end with a dash. You can also have numbers, but you can't, I don't think you can have things like hex or dollar or percentage sign. But if you create a VM, for example, a Windows VM, you are bound to 15 characters, but you can have uppercase, you can have numbers, and you can have dashes. But if you create a Linux VM, it has to be all lowercase, no dashes, and lowercase and numbers only. No symbols as well. Yeah. So yeah, so that statement is generally true. Okay, so this deployment is complete. If I go into resource groups now, and I go into test, you can see that this storage account has been created as part of this resource group. And if I go into this resource group, can you see all the tags that have been automatically created as part of this resource group, right? Because this resource is now inheriting the tags. And so if you think from your user standpoint, if they start creating resources on Azure, making them tag their resources is something that's going to be challenging. But if you implement this policy where they just have to create the tags once when they create a resource group, and everything that they create within the resource group will inherit all of those tags, then you don't introduce an additional pain for them, but at the same time, you can keep your resources in control, right? Be it billing perspective, be it automation, be it a management or administration perspective. Okay. Cool. So for the past hour, can you see that really it's important to understand the governance and how Azure subscription level works before even creating your first resource, right? Now, let's go into the topic of networking. And for that, I will also have demos to show you, right? Okay. So for Azure Virtual Networks, say if this box represents a virtual network, let me call this VNet 01. You can have, so with this VNet, right, it's akin to VLANs that you have on-prem. So for those of you who are familiar with networking, but only on-prem, then you would be, the likelihood of you creating VNets is like the likelihood of you creating VLANs. If you have multiple VLANs within your on-premises environment, chances are you're going to create multiple virtual networks within your Azure environment. So within a virtual network is also defined by its address space. So let's say if this address space is 10.10.0.0/16, this would mean that there are IP addresses from 10.10.0.0 to 10.10.255.255. So can anyone tell me how, I'm sorry, I'm used to asking interactive questions in my customer engagements, but the number of IP addresses that I have in this space is essentially 256 times 256 in theory, which is a really huge number. I think it's 65,000 something. I can't remember the number. Okay. If this number is not 16, but let's say if this is 24, then this would just be 10.10.0.0 to 10.10.0.255. And in total, there will be just 256 IP addresses that you can create from this range. We can have a separate discussion offline on how this translates to this, and that's got to do with binaries, but it will be out of scope for the presentation now. Okay. So if I have a virtual network of address space 10.10.0.0/16, I can then create subnets. Right? So let's say if I create a management subnet, this can be 10.10.0.0/24, which means it occupies 10.10.0.0 to 10.10.0.255. Okay. You can also create another subnet here. Let's call it web. We can also give it a smaller range. Let's say 10.10.1.0/25, and you will have 10.10.0.0. My bad. 1.0 to 10.10.1.127. Okay. So what I'm just trying to show you is, first and foremost, if you create subnets, the IP addresses cannot overlap. You cannot have another subnet that also occupies the same IP address range as, say, a management VNet, not even if just one IP address overlaps. That is also not allowed. So for those of you who are on-premises network engineers, this would be nothing new to you. But for those of you who are developers, bear with me. This is going to be out of your subject matter expertise domain, but in the area of networking, it's very important. Okay, so what I've demonstrated is you can have subnets of, say, here, right? You have 256 addresses in theory, and there's an asterisk here that I'll go into. Here you have 128. You can also create smaller or bigger ones, but generally they should be in the power of 2, right? Once again, that's to do with the design of this CIDR notation. And this is represented using binaries first and foremost. And let me now expand on why there's an asterisk here. When you create a subnet within Azure Virtual Networking, every subnet that you create, you will incur at least 5 IP losses. So what I mean is, let's take a look at this range, 10.10.0.0 to 10.10.0.255. So 10.10.0.0, 10.10.0.1, 10.10.0.2, 10.10.0.3, and 10.10.0.255. These are all reserved, which means they are IP addresses that you cannot use. Right? These 2 IP addresses are used for DHCP services within the virtual network. These are used for DNS, and this is undisclosed. Okay. So if you have, excuse me, if you have a subnet of 256, right, 256 in length, the number of useful IP addresses is 256 minus 5 equals to 251, which is not a big deal, right? But let's say if you create a really small, let's say if you have just 10.10.0.0 to 10.10.0.7. In this case, you just have 8 IP addresses, minus 5 reserved, you're left with 3. So in this case, the amount of IP address loss is greater than 50%, which is, unless you really mean for this 3, we don't recommend you to segment your subnets into such small ranges. So that's something you can technically do, but we don't recommend it. Okay. Another thing that we don't recommend is to stick your subnets together. What do I mean by this? Can you see that if you have 10.10.0.0 to 10.10.0.255, if you plus 1 to this, what is the value? Right? If you plus 1 to this, it's going to be 10.10.1.0. So can you see in this scenario, what happens if you run out of IP addresses here and you need to expand this subnet? Right? You're stuck. You can't expand it because the way to expand it is to increase this number. So if you are using 10.10.0.0/24, you want to expand it, you should change this to 10.10.0.0/23. So while you have 256 IP addresses in this segment, which is, can't remember, So 2 to the power of 8 is 256. The next choice that you have is to change it to 23, which is 2 to the power of 9. So the next range that you have is really 512. So here you will get 512 IP addresses, which spans from 10.10.0.0 to 10.10.1.255. And there are 512 IP addresses here. You cannot have something like 10.10.0.0/23.5. This is not allowed. This is not a valid CIDR notation. Okay, so in this case, if you're going to create a /24 here, this shouldn't start at a 1. As a matter of best practice, we recommend that you start this at a 2, right? Just so this is 2, this is 2, right? Just so that if you need to expand on this subnet, you have the choice. It's very rare if you create a 65,000 IP address range, it's very rare for you to be able to use up all of those private IP addresses. So you should leave gaps between your subnets where possible. If you have created this, and if you have allocated VMs and network interface cards that are part of these subnets, then you really don't have the option anymore to go back without downtime. You have to shut those VMs down or change those VMs from one subnet to another while you remove this subnet, just so that you can expand your original subnet and then recreate a new subnet and move the VMs back, which is a painful operation. So you should avoid it. So from a virtual networking standpoint, you should absolutely do planning. You should actually do an inventory check on how many virtual machines or infrastructure nodes that you are going to create, or you have plans to create, not just now, but also 5, 10, 15 years into the future, based on anything that you have visibility on. How should you design your virtual network so that it is sustainable towards, for the foreseeable future, right? So I have had customers who have adopted, right, this best practice. They told me, right, they told me when I was doing marketing that they're really not a big company, and really, just 8 IP addresses is enough for every, sorry, not 8, but 16 IP addresses is enough for every subnet. And I tell them, why scrimp? It's not like we're charging you any extra just for creating bigger IP address ranges. So why do you want to scrimp? It's not like that IP address range is being used for on-premises. It's not like it's being used for connected networks, which you cannot overlap. And they said, okay, fine. Then they just went ahead and did created in bigger ranges. And down the road, they are now needing to expand, right? They expanded very rapidly. They're an IT company, and the number of nodes within each subnet has gone over 32. Right, and so in those cases, you may not have foresaw your business growth, but you should always plan for it. In case that happens, your transition shouldn't be a painful one. That's what I'm trying to say. Okay, right. So at this point, right, I've gone through this simple theory of virtual networks. I can see that multiple people have dropped off. Usually networking is a very boring chapter for anyone who does not do infrastructure management. But for those who do, this is a very important piece. I'm going to show you some demos. If I go into my Azure subscription, if I go into virtual networks, and if I go into, let's say, just this infra VNet Southeast Asia, and I go into the address space, can you see this is the address space that I've allocated for this virtual network? I can add additional address spaces, but this is only at a virtual network level, not for a subnet level, right? Within a virtual network, I can have subnets. And these are all the different subnets that I have and the respective IP address ranges that I have. Okay. Right. So once these subnets are created, you can then create a VM and join them into these subnets. Okay. So as a matter of demonstration, you can see that under virtual machines, say this is a virtual machine that belongs to the Infra VNet Southeast Asia virtual network, which and underneath that network, it belongs to the web subnet. Okay. And this machine has a private IP address of 10.10.1.4. Okay. Now, the next question to ask is, can two virtual networks talk to each other? The answer is yes. Yes, they can, but you have to do something first. So let me simplify the diagram to just a box to represent a virtual network. So let's say this is VNet 1, and you have a VNet 2. Okay. So when you have two virtual networks, by default, they cannot speak to each other. This is what we call software-defined networking. When you create a new software-defined network or virtual network, you are creating a logically segregated space. And it's by design that both virtual networks do not speak to each other. As a result, they can really have the same IP address range. Right? It's fine. Right? It's fine because they don't have to speak with each other. So there's no point of ambiguity that is introduced in the environment. However, the moment that you need to create a network to join them together, you cannot have any overlaps. Right? So for example, VNet 2 can be 10.11.0.0/16. Even this, we don't recommend. Why? Just in case that you want to expand this and you want to have continuous IP address ranges. So you might want to create these to be 12 or even just, so in fact, you shouldn't even create 10, right? Because this should be a power of 2. So you can be 10.0.0.0/16, 10.4.0.0/16. And once you have these two created, there are two different IP address ranges. You can then connect the two networks together. On connection, there are two ways. The first way is called peering. And it's a logical connection. It's a logical two-way connection between two virtual networks. And you are essentially joining the two virtual networks together. When you do this, the two virtual networks behave like one big virtual network, right? Resources within virtual network 1 can communicate with resources within virtual network 2 and vice versa, unless you have firewall or NSG rules that prevent that. All right. The second method is you have a special type of resource called a VNet gateway, or virtual network gateway, or commonly known as a VPN gateway. And every VPN gateway will expose a public IP address. Okay, and then these two VPN gateways can then communicate with each other over the public internet. But these will be your VPN tunnel. So a workload here can theoretically communicate from here, to here, to here, and to here, right? They will still communicate using private IP addresses, but the traffic essentially goes up onto the internet and goes back into the other virtual network. Whereas for peering, the traffic goes across the Azure backbone, and you don't have to spin up gateways just for that communication. So gateways cost money. They are like there are two virtual machines worth of compute instances powering each gateway. You don't have to set up the gateway beyond spinning up on Azure. This is what we call a platform service. You don't manage the underlying code. You simply create it and use the control plane to control the connections. Right? So when you create these kind of connections, because of the nature of VPN, there is encryption. But for peering, there is no encryption. Why? Because for peering, all traffic goes on to the Azure backbone, right? Everything flows within our private links, either within the same data center or across different data centers. Oh, one thing, Azure has like 54 regions, I think, today, right? And we have more than 120 data centers worldwide. All these regions are connected using a mesh network. So we have private connections between all our regions that are powering Azure. So we do have the capability to route traffic privately without going across the public internet, right? So now, let me further simplify the diagram. I was drawing two virtual networks, right? VNet1 and VNet2. The two virtual networks are connected together. This is really nothing special, but what happens when a third virtual network comes into the picture? So you then have to make the decision: are you going to create a mesh network, or are you going to create a hub and spoke network? So the difference is, this is what we call hub and spoke, where VNet1 acts as a hub, VNet2 is a spoke, and VNet3 is a spoke. So if a node on VNet3 needs to talk to a node on VNet2, then they cannot directly talk to each other, right? They have to go through what we call a network virtual appliance within virtual network 1, just so that the traffic can flow to virtual network 2, a node in that virtual network. So why do we have this kind of architecture? A lot of the times is because huge enterprises have this concept of shared services. And these could be things like DNS servers, could be things like domain controllers or AD, Active Directory, could be things like firewall. It can be a northbound firewall, north-southbound firewall, or east-west firewall, and many other things, right? So when you have all these shared services, and you know very well that all the workloads within your environment will consume these shared services, it makes sense to group them into one virtual network of their own. Why? If you look at the nature of all these workloads, who is usually the team who governs all these? It's the infra team, right? So it makes sense to group all of these components within the hub network, and the infra team is given access into the hub network as well as all the components that are created within the hub network, right? And what are these spokes then? This could be your HR application. This could be your finance application, so on and so forth, right? So when you have this kind of approach, then it makes sense that the HR applications, the VMs that are powering the HR app, would have joined the domain controllers in the hub, and the finance application would also have joined the domain controllers in the hub, and any internet-bound traffic or traffic down to your on-premises network will have to go through your north and southbound firewall, which is also in the hub, right? So at any point, most traffic is just one hop away or one virtual network connection away instead of two. So this is a hub and spoke approach, right? Rarely, but they do exist. I've seen mesh approaches. So this is VNet1, this is VNet2, this is VNet3. They are linked together using a mesh network. So what I mean is every single VNet is just one hop away from every other VNet, right? So let's say if you have a VM here, in order to talk to the VM on VNet, it goes across this bridge, and it's just one hop away. What's the consequence? Well, you can't really control the traffic. If these two wants to talk, it can completely bypass VNet1. And that's because VNet1 is not functioning as a hub. It is just a regular VNet. It can be, this could be application 1, this could be for application 2, and this could be application 3. So it's in smaller organizations that I see this. This kind of network layout is also more hectic because this is 3 networks and you have 3 connections. If you have 4 networks, then the connections will exponentially increase. There is a formula to calculate this, but I'm bad with math, so I won't embarrass myself. So And if you have 5 networks, it's even going to get messier. We don't generally recommend this. The hub and spoke approach is generally welcome. It's highly adopted by a lot of customers. For smaller customers, you really don't need to have many different VNets. You just have one VNet and it should suffice for everything. So instead of having a hub VNet, instead you can have a hub subnet, right? And then you can use either network security group rules to do filtering or Azure Firewall to do, again, traffic filtering. Thanks, Alice. I appreciate that sentiment. Alice says, just wanted to cheer Stephen up as he's worried they're not interested. Yeah. So, when I talk about this this topic, a lot of people are switch off because if you are from application, this is not really relevant to you. Thanks for the comment. Okay. So let me now show you demos of how this. Oh, sorry. There's one other thing that I forgot to mention. For a lot of customers for hub network, there is also a connection down to the on-premises network. And for this to happen, you must have a gateway. There is a gateway here. There is a gateway here, right? This gateway is the exact same thing I talked about here, right? So for connections from Azure to on-premises, there are really 3 different ways of connection. So the first is point to site. Second is site to site. The third is express route. So point to site is like if I have an on-prem PC, right? In this PC, I have a VPN profile. And this VPN profile allows this single node to connect to the gateway on Azure. So then I can communicate with all the resources within Azure using private IP addresses. So I don't have to connect my entire environment to the Azure Virtual Network. I just connect single PCs. And the way I do that is through certificates. I need to generate certificates and upload that certificate data as configuration into the gateway. I will also have a demo of this. The second way is for site to site. Site to site is when your entire network on premises is linked or connected with your virtual network on Azure. Okay, so if you have a gateway here on-prem, you have a gateway here on Azure, you can then connect them using the public IP addresses of both. I'll also have a demo for that. And for Express Route, Express Route is what is a special thing. We like to market it. I know because I was from marketing. We like to market it as, a direct connection from Azure to you. Okay, so by you, I mean like your enterprise data center or your on-premises network. So in reality, it's not so simple. Express Route is actually a connection indeed from Azure to you, but there is a middleman. This is what we call an Express Route partner or ER partner. Okay. So ER partners are people like Singtel, or I'm sorry, we do have a list on our documentation. I just can't remember that list. So what happens is, as Microsoft Cloud operators, we will lay direct cables from our backbone to the ER partner, and we make sure that we allocate enough bandwidth to the ER partner, and the ER partner will know that the bandwidth that they have to work with, so they don't oversell their dedicated connections, and then you will not be in direct communication with us, Microsoft. Instead, you will be communicating with the ER partner that we engaged. So one of them, for most countries, we have quite a few to select from. And the ER partner will be responsible in pulling a pipe from their data center to you. So they are kind of like a switch operator. Okay, so the end effect you get is like an almost direct connection to Azure. And the traffic does not go onto the public internet, unlike the point-to-site and site-to-site connections, which are essentially VPN-based. So you do tunneling. You don't do You don't do a direct connection. Okay. So now let me show you all of these in demo. All right. So let me just go to my virtual networks. VNet Southeast Asia, as you can see here, this is my hub network. I have East US and UK South. East US and UK South are connected to Southeast Asia, and Southeast Asia is also connected to my on-premises network. So, excuse me. So let me just go into this virtual network. And within this virtual network, you can see that if I go into subnets, I have a subnet called Gateway Subnet. So in order for you to create a gateway within virtual network, you must have the gateway subnet, and you create it through using the button here. Once you have it created, you can't create another one, and this button will be blanked out. Okay. Okay, I'm seeing some comments that, hey, okay, I need to talk to Chun Lin. So I see that the maximum quality that this can go up to is 480p. I'm just wondering if there's a way to go up to 1080p. Okay, so in the meantime, let me answer some of the questions, because I can see, I can understand that you can't really see what's on the screen. Okay, so let me address some of the questions. Can VNet peering be unidirectional? Yes, it can. You can set up VNet peering so that's only, so the way that you set up VNet peering is both virtual networks have to authorize the connection. But when you set up the connection, you can set up from one to the other virtual network as allowed traffic, and from the other network back to the original network to be not allowed. So it can be one directional. Okay. What is the benefit of gateways over peering? So this is subjective, but as I was mentioning, for gateways, there is encryption for the traffic end to end. There are some customers that I have worked with who have the like a business requirement for all traffic to be encrypted. So for them, they can only choose the gateway method for them to stay in compliance of their own company policies, and peering would not have been compliant for them. Okay, so encryption is one of the pluses of having gateway connection. But historically, gateway connection was the only way for you to connect to virtual networks for a period of time before we introduced peering not too long ago, just a few years ago. Okay. Oh, Chun Lin was saying that after the video is streamed, it's not possible. Okay. So I think that answers the question. I will try to show things bigger, but that would slightly limit the experience. Sorry for that. Okay. Okay. On cost, I'm not good with cost. So like one thing that PFEs don't do is sell. We don't sell the product, so we have absolutely no idea how everything is costing. I know, for example, if you create a gateway, right? If you create a gateway, this would be like 120 USD a month. This will be another 120 USD a month. On top of that, you will also incur traffic outbound. Whereas for peering, you just incur the traffic outbound without having to incur the cost of the VNet gateway. But if you create VNets, right, we don't charge you based on the VNet. You can create like 20 VNets and it's still free if there's no traffic going anywhere, right? Okay. But if you ask me to do a calculation, then I need to bring out the Azure calculator, and I'm not good with that tool. It's not something that I usually work with. Okay. do you by default allocate subnets based on regions? So when you create a virtual network, you will pick a region. Any subnets are going to be part of the virtual network. You will have no option to pick regions for subnets because subnets are not resources on their own. Subnets are just configuration of VNets. Once a VNet is created in a specific region, every single node that joins that VNet has to be of the same region. So you cannot create a virtual network in Southeast Asia, and then you create a VM in UK South and try to join that VM into your Southeast Asia VNet. That is not allowed. Okay. However, you can create a virtual network in Southeast Asia, a second virtual network in UK South, and you connect the two networks together, either through peering or through gateway, and the VMs from both locales will still be able to communicate with each other. That is okay. Oh, you want to know the rough cost of express route? I'm really not the right person to ask. I really don't know about that price conversation, because that's a conversation our sales team have with the usually the business decision makers of our customers. So I'm not involved in those conversations. We do have documentations on it though. So you can check this out and do a rough calculation, but you should bear in mind that this calculation does not take into account the traffic flow. Any traffic ingested into Azure is not billable to you. Any traffic that goes out of Azure is billable to you. Okay. Right. So let me just go back to the demo. I know we have just 25 minutes left. I just want to squeeze in as much of the demo content as possible. So I'm just going to upsize everything to 125%, and I'm hoping that could help you see a bit better. Okay, so I was trying to show you within Southeast Asia, within this VNet, I have a gateway subnet. And within this gateway subnet, if I go into connected devices, can you see that I have a virtual network gateway, right? This virtual network gateway is part of the gateway subnet. Where is this gateway? Infra VNet Southeast Asia gateway. Okay, so if I go into virtual network gateways and I go into this particular gateway here, as you can see that this virtual network gateway has a public IP address, right? So this public IP address allows other gateways and other on-premises network edge devices to connect to it and create a VPN tunnel. If I go into user VPN configuration, you can see that I have a configuration of the virtual network gateway using certificate information. So this is public cert information. So this is using asymmetric key generation. So if I go into my certificate manager, I do have the root cert that is planted into my current machine. So that public cert is created from this root cert. So these two are a match. So traffic between the gateway and my local PC can be encrypted using this algorithm. And I'm sounding very layman here because the security algorithm is not, or encryption is not my subject matter expertise. But if you take a look at this PC that I'm using, can you see that I have a VNet gateway or a VPN connection here? So this has been set up using this VNet gateway. If you just download VPN gateway, you will download the configuration to set this up. So if you have this, so right now I'm not connected, right? Just to prove my point, if I go into this infra jump host virtual machine that is part of this infra VNet Southeast Asia virtual network, part of the management subnet, I can try. So this virtual machine does not have a public IP address. It has a private IP address though. So I can try to connect to this IP address, and you'll see that it won't work simply because my home network is not currently connected to the Azure Virtual Network. So here, so you'll see that this connection will fail. And I think I will not wait as long. Okay, so the connection fails, but if I go back to if I go back to my network settings, and if I just press connect, I will get a pop-up window asking me to connect to Windows Azure Virtual Network, and I will click connect. Yes, and this will, oh, interesting. I think my net, oh, okay. Sorry, just let me. So it says failed, and I don't have a matching certificate information. So I'm not sure if my certificate expired. Could have. Oh, crap. A moment. You know, this was working just last week, but I guess. So it just expired 3 days ago. Okay, it just expired 3 days ago. Okay, so I'm not gonna work this on screen. I know we just have 20 minutes left. I can save this to the next session once I fix this, because I will fix this. Once I fix this, I can then show you certificate-based VPN connection. But the experience that I'm supposed to have is if I just go in here, I just connect to the VNet gateway using. I just install this VPN profile. We can see that will install the profile here. I can press connect, and once I'm connected, I will be able to communicate through private IP address. I'll take that as an action item to get this fixed. Okay. So what I've just talked about was point-to-site connection. Okay. Now let me show you site-to-site connection. Okay. For site-to-site connection, I have a virtual machine running in my environment called Our IaaS. So an Our IaaS is basically a Windows server that has a remote connections service enabled. Okay. So within this virtual machine, you can see that I have an Azure VPN configured under routing and remote access, RRAS server, routing and remote access server. So for those of you who can't see the public IP address, that's 13.76.220.1. What is this IP address? Okay, if I go back to the gateway and I just go into overview, can you see that I have, this virtual network gateway has an IP address of 13.76.220.1. Okay, so that is the public IP address of my virtual network gateway. Okay, so what I'm showing you is essentially the IP address here. Likewise, I need to configure my public IP on-prem to here so that the connection can be bridged, right? So where is that setting? So if I go into connections, you can see that I have a site-to-site virtual network Southeast Asia connected to my home network. I just click into that, go into configuration. Let me just, okay. Can you see under overview, I have a local network gateway, infra site-to-site, VNet Southeast Asia home. And this is the public IP address of my home network. Okay, just doing a Google search for what's my IP. Can you see that my IP address, which is 121.7.131.18, right? This matches up with this configuration that I have. So this is an endpoint that I have, 121.7.131.18. All right. So once I have this IP address, and I get the two networks connected, so I need to make sure that the connection status is connected. Once this is connected, then at this point, this very virtual machine itself can start behaving like a gateway. So I can point many other virtual machines to this virtual machine as a gateway, and those will have access to my Azure network. So as an example, if I try to remote to 10.10.0.4, I will be able to hit my endpoint, right? So let's say if I try to log in, it's a bit embarrassing because I have a feeling I forgot my password. Okay, I remembered my password. I'm just going to create a new text document on my desktop, just so when I connect to that from my other VMs using this VM as a gateway, you will realize it's the same VM. So I'm just going to create this text document on the desktop. And then what I'm going to do is I'm just going to log out. Now, let me bring up another VM that will use this VM as a gateway. Try to use this one. So we're just going to go into the network and properties, go into adapter options, going to check this IPv4 settings. And for those of you who can't see, I have preferred DNS servers. Sorry, I have a default gateway that is 192.168.1.50. What is this IP address? So if I go into my RAS server and I do an IP config, can you see that I have 192.168.1.50, right? So that is the intranet or private IP address of my RAS gateway. Okay, so once this is set up, it means that all the VMs that use that RAS server as a gateway will have inherent connection into my Azure network environment. So I can go into remote desktop and I try to, again, hit the same endpoint. Right, can you see that I managed to hit it? And let me just try to log in. Can you see that now I'm logged into the same server with the same file? Okay, so this is the same VM that I was trying to access. And I don't have this IP address range in my own network, right? Because if you take a look at my LAN settings, I only have the IP address from 192.168.1.1 to 192.168.1.254. My mask is just /24. So I don't have a 10. Something inside my local IP range or my local IP address. Okay. So that was a demo of a site-to-site connection. And in a lot of your environments, you wouldn't have an RAS machine. That's not a VM that you would be running as a network edge. You won't receive a lot of enterprise support for that. I think a lot of you would have F5 equipment, Cisco equipment, checkpoint equipment, and those are very dedicated hardware and software that helps you connect to other networks as a gateway, right? All right. So I can't show you a demo on an express route, but I could only show you how the communications work. All right. So I know we have 10 minutes left. I also have to end at 8 p.m. because I have a customer meeting at 9. So I think the last thing so we were supposed to go through highly available or high availability options. I think I will try to quickly go through. For those of you who can stay, I might drag a bit. So in Azure, you have a few high availability options. So as an example, if you have a single VM with unmanaged disk, right? Our SLA to you, our uptime SLA to you is 0% because we don't have an SLA for a single VM with unmanaged disk. What is unmanaged disk? Let me elaborate on the next session, right? Okay, so unmanaged disk is essentially a VHD or VHDX file that sits within a storage account. This is the old way of doing things, right? Today, this should be, so today, if you have a VM with a managed disk, then first of all, our SLA to you is 99.9% uptime guarantee. And this managed disk is basically a disk object that sits within Azure. What do I mean by this? If I go into this virtual machine and I go into disks, can you see that I have a disk here? I know this is a managed disk because once I click into the object, I can see this is a disk type. This is not a VHDX or VHD blob inside a storage account that I can download. I still can download this disk. The difference is I cannot re-upload the disk because that process often breaks the VMs that our customers run. Okay. So, but both of these are what we call single points of failure. And the problem with this is if just that one virtual machine goes down, be it as part of platform maintenance or be that part of one of your operations, like if you have to do a Windows update, then as soon as that VM goes down, all the workloads that are running on that VM, it could be a website, it could be an application server, they will all become unavailable, right? That's how servers work. So this, if I do an Azure solution assessment, then I check your environment and I find these single points of failure. I will call them out, and these will be called out as major risks. Of course, for some customers, they are fine with the risk and they will not act on it. That's okay. You have accepted the risk. But for some other customers, that can come across as a shock because when they do plant maintenances, their workloads will go offline. So then what are your highly available options? Number one, availability set. And for availability set, what you are creating is essentially you are duplicating that one VM into two VMs. And then you put them in the same availability set. But the difference is you put this into different update domains and fault domains. So the first VM might be update domain 0, fault domain 0, update domain 1 for the second VM, and fault domain 1. What's an update domain and what's a fault domain? So an update domain is basically anytime if we need to do scheduled maintenances for virtual machines due to platform repairs or platform upgrades, then we will shut down or restart virtual machines by update domains. Which means to say, if we are in the process of starting or restarting virtual machines in update domain 0, we will wait for all these virtual machines to come back online before we shut down or restart the virtual machines in update domain 1. So if these two virtual machines are hosting the exact same, say, application or website, then if you put a load balancer in the front, which is load balancing traffic across the two virtual machines, then even if one of them restarts or becomes unavailable, traffic can still be served by the other VM, right? What is fault domain? Fault domain just means rack. So rack is basically, VMs within a physical machine sitting in a physical rack. If you put two VMs within two different fault domains, you are saying not only do those VMs not sit within the same physical host, they also not sit within the same physical rack. So if we do have a rack level failure, your other virtual machine will still be running, right? That's the concept. Now, in this model, we give you an uptime SLA of 99.95%. Okay, next. Availability zone. So for availability zone, it's essentially the same architecture. You have two or more, right? So this can be n number of VMs, same with this, n number of VMs. The fact that you have more virtual machines does not increase our SLA to you. But the moment that the number of available VMs drops below 2, you will get just 99.9% for matched disks and no SLA if you're on unmatched disks. Okay, so again, you have something like a load balancer or an application gateway that sits in front of the VMs that does traffic routing into two VMs, except that instead of, so for availability set, right, okay, all the VMs are within the same data center. And for availability zone, you will configure zone. So if this is zone 1, this can be zone 2. Usually within a region, there are more than one. Usually there are 3 zones. So what is zone? Zone is just our term for data center. So when you put VMs into 2 different zones, you are saying I put VM1 in one data center and I put VM2 in a different data center. So if we do ever have a data center level outage, then traffic can still be forwarded into a different VM belonging to a different data center, right? So this, you will get 99.99% uptime SLA, slightly higher, right? Okay. And the third option is really, I'll call it version of 1.5. This is VM scale set. So in VM scale set, what you do is you first declare a collection of VMs. And within these VMs, within the availability, the scale set, you have what we call instances. So scale set is something that is being improved on right now. So the default mode of operations is the VM scale set orchestration mode. In VM scale set orchestration mode, all these VMs, and I'm drawing 4, but this is arbitrary, between 2 or between 1 and n, all of these VMs are exactly spun up from the same image. Okay, this image could be your custom image, or it could be one of our marketplace images, right? So if you have many different instances, what happens is you can use dynamic rules to spin up the number of instances and spin down the number of instances. We call it scaling in and out. So you can set rules like if the average CPU utilization hits above 90%, then plus 1 instance. You can set rules like that. Okay. If average CPU utilization drops below 60%, then decrease 1 instance. And so what the VM scale set does is it looks at the number of instances you have. It makes sure that it does not exceed the number of instances that you have specified. And where the conditions hit, typically this is in the 10-minute duration. So you don't spin up and spin down VMs just for spikes. So say if 10 minutes, the CPU utilization of all the VMs combined on average is above 90%, then the scale set will automatically spin up 1 more instance using the image. And then you will have 1 more VM in that pool that traffic can be routed to. Okay. So this is VM scale set, but on the back end, VM scale sets are powered by availability sets. So you have the same SLA, as availability sets. Okay, so in terms of high availability options, you really have two different kinds. And here I would like to show you a demo. And I think after the demo, I'll end the session here. Okay. So let's take a look at my Azure environment. I'd like to show you an application that I have hosted. PHPDB is an open source PHP-based forum software. So if you go to phpdb.com, you can download the binaries from the web page and just click on download, and it will download a zip file. You just have to host that in Apache or a PHP-enabled server. For me, I have, so let me just scroll to the right and group according to locations. We can see that I have 2 VMs in East US. I have 2 VMs in Southeast Asia, and I have a VM scale set in UK South. Now, my 2 VMs in Southeast Asia are part of availability set. So I'm talking about this. Okay. So for availability set, you can go into any one of the virtual machines. And if you take a look at availability and scaling, let me just try to increase to 150%. If you go into availability and scaling, you can see this VM has fault domain 0 and update domain 0. Okay. Now, if I go into the other VM, web VM2, again, I go into availability and scaling. You can see this is fault domain 1 and update domain 1, and they belong to the same availability set. Right? In front of this availability set, I have a load balancer that is also based in Southeast Asia. So if I look at that load balancer, I can take a look at the backend pools. You can see that I have the 2 web VMs that I have configured as part of the backend pool. And I have a health probe probing them on both ports 80 and 443. And that health probe is essentially every 5 seconds checking whether, if it does a ping, not a ping, but a connection test at that specific port, is the VM alive? And if the VM on 2 consecutive counts does not respond, then the load balancer will mark that VM as unavailable and stop routing traffic to that node until that node starts responding again. Okay, so the load balancing rule, one using one on port 443, the other on port 80. So it just says that, okay, I am using this front-end public IP address. I am routing traffic to port 443 from port 443 to backend port 443. The backend pool is the 2 virtual machines I shown you earlier, and the health probe is that port 443 health probe. So session session persistence. This setting has to do with how stateless your application can be. If your application can be fully stateless, then you should choose none, and traffic can be routed to any one of the VMs. But we know that a lot of applications today run on legacy code, where hosting an application on a monolithic VM is the norm. So what you get is a lot of applications cannot work in this randomly assigned VM mode because of session information, because of storage being persisted onto a local C or D drive, that kind of, you should never persist information to D drive on Azure. But if you have locally persisting data, then you might need to use IP or IP and protocol persistence. So any traffic connecting from the same IP or from the same IP using the same protocol will always be routed to the same VM so long as that VM is available. Okay. So in a nutshell, that is a load balancing. And I can show you for this load balancing, I have, this is the public IP, but I have a domain that is routed into that IP. Okay. If I just do a ping sg.mdyn.org, can you see this domain that I have configured is pointing exactly to this IP address? So now, if I just go into a new tab and I go into that URL, you will be able to see, this is strange. Okay. I did. Okay, this should not be this color. The last time I configured this should be pink. Okay, so this is sg.mdy.org is being currently served by web02, right? Okay, let's try that again. It's still web02. Why? Because I have IP persistence, right? IP persistence. Now, I'm going to do something very catastrophic. I'm going to turn off VM2 because I'm served by VM2, right? So I'll go ahead and go into web02, and I'll stop the VM. So you will see like a 4 seconds unavailability on this web page before the page is before traffic is automatically routed into VM1. I'm not sure why it's so slow for me today. Yeah, so it was so slow I could not show you that 4 seconds offline message, but you can see from the web page at the bottom it says web01. So now the load balancer has cut traffic to load balance the VM2 and is now routing me to VM1. Okay. Next, let me move on to I think it's US. So in US, my VMs are set up using availability zones and not availability sets. So if I go into this VM and I go into availability and scaling, you will see nothing because this is not part of the availability set. Instead, in overview, you can see that for web03, my availability zone is 1. Okay, my availability zone is 1. Now, if I go into web04, then my availability zone is 2. So this means that Web3 and Web4 are fundamentally in different data centers. And this is the US site. So I go into us.mdyn.org. Okay. Once again, if I go to the bottom, can you see I'm now being served by Web04. So if I go ahead and shut down VM04, then the traffic will swing back to VM03. Okay, so this is an example of availability zone. Next. Finally, I'm going to show you the VM scale set. So in VM scale set, you can see that there are a total of 5 fault domains. And this is the first hint that this is using availability set. Because when we talk in terms of fault domains in the context of virtual machines, then we are really talking in context of availability set and not availability zone. If I go into instances, you can see I have 2 instances that are running. I did not manually create these instances. Instead, if I go into scaling, I do have custom policies used for it. So I have a scale out rule and a scale in rule. If I just show you the rules, it's actually very logical. Sorry. If the average, so percentage CPU is my measurement. If the CPU utilization goes above 70% for a continuous 10 minutes, and this means it's average, then I will increase the number of instances by 1. And for the next 5 minutes, when the new instance is being created, I'm not doing any form of measuring. So there will be a 5 minutes cooldown, and then 5 minutes later, it will then start measuring again whether there's a sustained spike for more than 90% or 70% in my case. And if it's still above 70%, it will spin up another instance. Of course, I also have a scale in rule. So if I click into that scale in rule, this is again percentage CPU. If it's less than or equal to 50% for a duration of 10 minutes, then I should decrease the count by 1. But in order to have high availability, I make sure that I have minimum 2 instances that are alive. And the maximum instance is more of a cost factor, right? If You don't want this thing to spin up 1,000 VMs and you have to pay for 1,000 VMs worth of compute cost. So this is as much as your cost budget for this application goes. For me, it's 4, just for demo purposes. I have seen this going up. I think in context of Windows updates, this tends to go up because I'm on the lowest possible scale. Now, one thing that I didn't mention earlier is if you use VM scale set, every single instance will be the same size. So if you chose a VM scale set of 2 cores and 8 gigs of RAM, then every instance within the scale set will be 2 cores and 8 gigs of RAM. Whereas if you use availability set and availability zone, because you manually add virtual machines into the backend pool, you can have vastly different configurations for the different VMs. For example, for one VM, you can have 64 cores and 32 cores and 128 gigabytes of RAM. For the other VM, you can have 1 core and 3.5 GB of RAM. That is up to you. Okay. So now let's take a look at uk.mdyn.org. I did not bother installing the SSL cert on this, so this is defaulting to no SSL, but you can see this is hosted on a VM scale set. If I shut down one of the instances, this will remain available as illustrated in high availability options. Now, there's just one more thing that I did. So I have shown you pretty much I have 2 VMs in Southeast Asia, 2 VMs in East US, and a VM scale set with 2 VMs or 2 VM instances in UK South. And of course, they all have their own load balancer. So the load balancer is responsible for load balancing traffic. As you have observed, they all run the same thing, right? They're all essentially PHP BB applications. Now, I can make this a truly globally distributed solution just by putting something like a traffic manager in front, or front door. So a traffic manager operates at a global level. You don't choose which region does the traffic manager belong to. Actually, you do choose that, but the traffic manager is, once you have created it, it's globally distributed. Front door is the same thing, except front door has a web application firewall. So if you choose load balancer here, which is level 3 load balancing, it could be layer 4, I need to confirm this, but it does network level load balancing. It won't have things like web application firewalls and endpoint-based routing or packet inspection. Although if you do create this using an application gateway instead, then you get a layer 7 load balancer, which will also give you SSL termination endpoints, also give you a web application firewall. But if you create all these as load balancers and you want a WAF, you want a web application firewall, you can use front door. If you don't need the web application firewall, you can use traffic manager, right? So with the traffic manager, I can then route traffic to the respective different load balancers. And depending on where my traffic comes from, right, that traffic manager can route traffic into the nearest location. So as part of that demo, let me open up a tool that will help me ping the endpoint from multiple different places. So www.mdyn.org is an FQDN that is pointing towards the traffic manager's public IP address. And while that thing is loading, let me just show you back into my resource group, going back to PHP BB. And let me just show you that traffic manager. So first and foremost, can you see the traffic manager profile? The location is set to global. Right? It's not any particular region, it's global. If you go into this traffic manager, you can see that it's routing traffic to all the load balancers in the different regions. So as long as they're online, the traffic manager will show it as online. And depending on how you configured it, so what I mean is the routing method right now is geographic routing, which means I manually choose to say, traffic coming in from Antarctica, go to the US, traffic coming in from Ireland, go to UK, traffic coming in from Malaysia, go to Southeast Asia. You can configure things like traffic coming in from US to go to Singapore. So, you might have a reason to do that, but that is available to you. However, if you choose performance, then it will always route based on the least ping. Okay, so and if you choose weighted, that means it's a ratioed approach. Say if you have 3 regions, you can say 60% traffic goes to Southeast Asia, 20% goes to US, and 20% goes to UK. If you choose priority, then all traffic will constantly go into one region. Unless that region is down, then it will start going to the other regions. So if priority number 1 is Southeast Asia, then all traffic goes to Southeast Asia. And if the Southeast Asia endpoint is unavailable, then traffic starts to get routed to number 2. That could be US, then traffic will get routed to US. And the rest are just a combination of these different mechanisms. So I'll not go through that. Okay. So in GeoPicker, some are not available, but if you just observe based on the IP address, you can see for Southeast Asia, that's 52. So it ends with .56, right? It ends with .56. So Singapore and Australia are both routed to the Southeast Asia endpoint. The MS is different because the server is based in Singapore, so it's just 10 MS, whereas for Australia, it has to jump through a lot more networking hoops and crosses international boundaries. And if you look at for California, for Brazil, for Virginia, they are the same because all of them are being routed into East US. And for Ireland, they are being routed into 180, which is UK South. Okay, so this is a demonstration of how you can create a globally distributed application on infrastructure as a service. So that you have both high availability as well as performance tuned based on the location of your customers. Okay. So with that, I'm gonna end my session. I'm aware that I'm 16 minutes over. I'm sorry for that. I'm gonna pass it back to Chun Lin. Thank you very much for your time. And by next session, I will get the point to site working, and then we can talk about.
Hello. Okay.
Yeah.
I'm not sure whether you hear me or not. But thank you, Stephen, for delivering such a awesome content. Thank you very much, and especially staying late until 8+. I hope you didn't miss your dinner. By the way, sorry, just now I heard from Steven is that the resolution seems to be not satisfied. I will try to work on that because of the working from home, so I can't access my better machine in the office to do the streaming. Yeah, I will work on that. Thank you very much, and thanks everyone, especially Marvin, for helping me also. Hope to see you all soon next week. I think let me go back here. So just now Steven has guided us through these 2 topics. So next week we will continue with these 2 the remaining 2 topics. Okay, so hopefully some answer questions next time you all can bring to here as well. Don't be too shy. But I hear from the Steven sharing just now, it seems like today's we have a very good response. Thank you all for your support. And if you really want to give Steven more support, please like our videos, and hopefully to see you all next week at the same timing. Thank you very much and stay safe. Thank you. Bye bye.
Bye everybody.